Well, hello everybody again. We are progressing through our chapter on inequalities. Remember, inequalities are fairly similar to solving equations. The difference is that your symbol is a little different. We don't have something that equals just a number or no numbers or all numbers. We can now have this equation that can represent a group of numbers. And we have been solving the ones that's either this side of the number line or it's that side of the number line. And now we're getting to just a slightly different aspect. What happens if it could be different sections? We're going to exclude portions of the number line this time. And these are called compound inequalities. So we're in chapter 3, section 6 of our Pearson textbook, solving compound inequalities. So what it's doing is, how do we represent solutions that have restrictions? They're basically saying they're going to restrict certain numbers, and we have to be able to mathematically write that down. With compound inequalities, we have two types. There are two types. One type is an and problem, the other type is an or problem, and they do look completely different. The way you represent your answers looks completely different. The and problems, you'll see here, your answer is in this like inequality notation over here where it says -2 less than x less than 3. This style will only use less than symbols. So you can only use a less than or a less than or equal to symbol. And what it's actually telling you is that your answers are somewhere in between -2 and +3. -2 and +3. And I can actually see a boo-boo that we have here on this particular graph. So let me see if I can fix that real quick. So instead of it going to 3 here, it's supposed to go here to -2. I'll see if I can just white that out. All right, we'll just leave that there like that. So there you go. Again, as a compound inequality and an and problem, you're looking at this, and when you want to read, the way to read it so that it's a better understanding of how we're learning this, it says that all of our answers that we should have should be somewhere in between -2 and 3. Of course, it doesn't include -2. It's as close to -2 as you can get because that's just a less than symbol. And same thing with 3. It doesn't include -3. So it's as close to each of those numbers and everything in between. When you look at this one over here, this is an or problem. So or problems, again, they're very different. You must type the word or. It has to go in between two little inequalities. So what this is saying is that our answers are going to be here. From x is less than -2, so x is less than -2, all numbers in that direction, or your answer is on this side, which is greater than. X is greater than 2, so all numbers greater than. Notice this time your numbers are excluded in the middle completely, and it may be excluded either on this side or this side. So our numbers are either on this side or they're on that side. But definitely no way, Jose, in any way, shape, or form, can any of your solutions be in the middle. This section is excluded. Let's see how these start to work, okay? So let's say we have, this is our first problem. And I can tell that this problem here is an and problem because it's written in this big chain with two different inequalities in here. In order to be able to solve this, what we have to do is we have to break this problem into two smaller equations. So this middle section here, as you'll see in just a second, gets used 2 times. So our first equation comes from here to here, and you see we've represented that part here. We rewrite it. The second equation will come again using the middle part and this inequality symbol to here. And from there, we start to solve it just like we would normally solve any equation. So we're trying to solve this for x. So we want to subtract 3. So it leaves us with a -9. Less than or equal to, and the x can come straight down. There's one piece solved. Now this one is the same thing. We are here and we're trying to solve this. So we want to solve for x. We subtract 3. 8 minus 3 is 5. These will cancel on us, just like these did. And the x can come down. And we carry our symbol down. Notice our symbols didn't flip or anything. We didn't multiply or divide by a negative. That's the only time we flip those symbols, is if we multiply or we divide by a negative. And as we go through, then we have our answers here, right? And it's kind of interesting. So depending on how it looks, look, we make sure the sign, that is a less than symbol, that is a less than symbol. -9, which is the smaller number, is on the left, 5 is on the right. What we do now to write our answer is, you have to think of it like this. We have to merge these two back together, because our answers are somewhere between -9 and 5. So when we go to rewrite that, we'll say -9. We use the symbol less than or equal to. We only need to write the x one time. The less than symbol comes by, and 5. And if we were to drop this on a quick number line, again, this is an and problem, so that means our answers are in between -9, including it, and 5, not including it. So you have -9 on this side. You'd have a 5 over here. This symbol means solid dot, and this symbol would mean an open dot, and it's in between, all the numbers in between. So our answers, again, would include 9 and go all the way up to 5, but not touching 5, the best that we can. Let's take a look at an OR problem so we can compare the difference. Now, the OR problems, I mean, they're already separated for us here. We have one inequality, we have another inequality. All we have to do is solve them. So I just draw a line straight down the OR and make sure you carry, or maybe make it an arrow if you want to carry the OR so you don't forget, because your final answer will have an OR in it. So what we're trying to solve for our x. Cancel, x is less than -5. Same thing here. We're trying to solve for that x, so we have to add a 5. And 5 minus 1 is 4. Oh, I totally didn't even see that. I said 5. Nobody corrected me. I didn't hear anyone. Look at that. That was actually a 4. I don't know where the 5 came from. So you add 4 to both sides. Boy, that would make a weird problem for us, right? All right. +4 minus 1 is a 3. And the x will come down. So now we have our problem. This is our answer. So it's x is going to be less than 5, or x is going to be greater than or equal to 3. Notice x's have to be on the left in these problems. And then you have your symbol, and then you have your number. Okay? And as you start to look at this, this was a -5. As you start to look at this, right? -5 is the leftmost, and then you have this over here. So you should be okay. We have to go ahead and graph. So as you start this, we look at this here, right? This is going to be an open dot, and it goes in this direction. This is going to be a solid dot, and it goes in that direction, and this is at the number 3. This is at the number -5. Right, there are a few more examples. Feel free to work some more out. Hopefully this gives you a taste of what this is all about.